Black holes, okay.
Yes, they have found a black hole that is vibrating at a perfect C.
A black hole that vibrates. They found one that yes.
And
Yeah, they
like
do.
80,000 octaves below middle C on the piano,
But that's okay. It's a perfect C. We need a perfect C. Do we have one? We need one that's like an A440 though. Yeah. It's too steep that light would have to go faster than the speed of light to escape from it, right? So in terms of the energy, right, the light would give up all its energy to get out of there, so it can't get out, right? That's another way to think about it. The escape velocity is faster than the speed of light. Yeah. Isn't that wild? Okay, so Einstein, escape velocity, how to explain? Okay. Yeah. Light gets in for light. Getting into a black hole is easy. You just go in, right? It sucks you in, right? Yeah. Never can get out. It's a singularity. Just collapse, stellar collapse. Yeah. Basically, black holes formed by the stars just getting small. Because what buoys a star up is the explosions, the fusion, right? As soon as that burns down, gravity just crushes it to nothing. And it becomes, some of them, if they're big enough, they become black holes. Okay, let me show you. Wow. Let me show you, and I think I have handouts for this, but I might not. Okay, these will be, the teacher has clearly lost control of the glass. Glass! Shut up. Could I have your attention, please? Could I please have your attention? These will be at, this is another thing like the Vernier lab. These will be at the station, and I'm just going to go through here. It says, start over, quickly type the OK. So the first thing I want you to do is just hit enter, see if you can get into orbit. Just hit the right arrow a few times and you'll go into orbit. The one thing you don't want to do is you don't want to head straight to the planet, right? Anything that involves that, right? There we go. If you want to be more precise, I'm hitting the up arrow and letting it coast. And when I'm above it, if I'm sort of coasting directly to the left, then I'll be in a nice, fairly circular orbit, right? So anyway, there it is. I hear there I hit the up arrow, hit the right arrow, okay? You just don't want to speed it up, right? And hitting the up arrow, I actually slowed it down a little bit is what I did, okay? So anyway, there's that guy. The next thing I want you to do is get it in, hit, and then hit O, let it go around, hit the R key 5 times quickly. Do you speed up or slow down? Well, you know that. What's the relationship? So draw a little picture of that relationship between the two orbits, right? And then compare the orbital speeds of a close orbit to a far orbit. Which orbit's faster? Draw a picture of your orbit. Where is it fast? Where is it slow? And talk about energy, right? So blah, blah, blah. Yeah? Okay. And then, yeah, blah, blah, blah. And then the second thing is, it says do new orbit. So I'm going to escape from the Planet of the Apes here. And then run new orbit. New orbit has, you can only speed up and slow down. Okay, so strike the any key. I think 30 is a good time increment. And why do you have to type in a time increment? Because computers get faster and slower. And so as computers get faster, we type in a smaller time increment to slow them down. I think 30 works, right? So there I am. And what I want you to do is I want you to practice by either only speeding up or slowing down. I want you to go from that orbit to the lower orbit or that orbit to the upper orbit, right? Okay, so let's try speed up. Let's see if I hit it 5 times. That wasn't enough, was it? Okay. Five times. Ooh, that's close. How about 2 more? So we've done a total of 12 speed ups. So that was too much. Okay, so I'm going to start over. Enter. Let's see. I'm going to hit 11 times. Almost, right? So you can figure it out trial and error. The other thing you can do, by the way, is you can program the fire. So hit P, right? And then enter an amount of fire. So I'm going to try 1500, right? And then if I hit R, it'll slow down. S, it'll speed up. So let's speed up. and 1,500 is too much, right? There it is, right? So obviously they do something like that with NASA or something like that, right? Okay, so anyway, you can do that. So you hit P, and then how much you want to do. Let's go 150, and then I hit R, and that slows me down or something like that. I don't know where I am. There I am, right? Okay, so you can do that. Practice going from the low orbit to this orbit to the low orbit, this orbit to the upper orbit, right? Make sure everybody gets a chance to fly it. And then there's a third one, and this is just for fun. So get those first two done, you know, because there's a question about this on the test. I ask you a question, what if you're in this orbit and you speed up, or what if you're in this orbit and you slow down? Okay, and then there's a bunch of them here. I think Apollo, this is the fun one, and I can't remember, what is a time increment? I think like 0.1 on this one, 0.1. What does it say? Oh, 0.1 to 0.3, so let's go 0.1. There we are in orbit around the Earth. Here's the moon. The moon actually moves. And in the 3 or 4 days it takes to get to the moon, it moves significantly in its orbit, so you got to like kind of lead it and all this stuff. This guy's not going to move, he's just stuck there, right? Okay, so I'm going to speed up. I think 7 might be a magic number, right? So we are in orbit, and remember that there's 2 depressions. There's a very small depression in space-time right here, a pretty large one right there. Okay, so here I am heading toward this sort of somebody knelt on the golf green and made a dent in it. Are you picturing that? Right? So to get my ball to go into that dent and orbit it, what do I have to do? I have to head to the side of it, and then I have to, when I get in it, if I don't slow down, don't I just go in it and then out of it again? I speed up going into it, slow down going out of it, and when I'm on the level again, I'm going the same speed, yes? Okay, so to get into it, what do I have to do? I'm going to do a little deflection here to the side. I'm heading too much directly toward it. I have to slow down, right? So I'm going to hit the R key here. I don't know, 5 times or something. So yeah, yay, I'm in orbit around the moon. Then we detach the lunar module. It goes down and lands on the moon. If it crashes, they die, because it's the thing that they need to use to get off the moon. Then they walk around the moon. They play golf, right? Somebody stays up in the upper thing, right? And then they blast off, leaving the legs. The little thing like the size of an SUV goes up, docks. Then they have to head home. Tegan's got a question.
I was wondering about like the 4th dimension thing. So does that mean that like all matter makes like a shape like that in the 4th dimension then?
Yeah, all matter warps it, and then string theory is, you know, when they talk about strings and stuff like that, those things exist in other dimensions. So it's like a chia pet, right? The dimensions that and the sprouts are like the little loops that. Okay, so now we need to get home. What do we have to do to get away from the moon? Yeah, speed up. And I'm going to go.
So, Murray,
there we go. Now we're headed toward the moon, the Earth. Oop, is that enough? Speed up a little more. I'm cheating. I should have sped up more. I'm in a hurry. I'm heading home in a hurry. Okay. And then to get into orbit around the Earth, what do I have to do? Slow down. Head to the side of the Earth and then go. Oh, go too fast. I'm lost in space. I'm gone. Bye-bye. I didn't slow down enough. So it's kind of an interesting thing, right? I'm sort of skipping off into space. Lizzie's got a question.
I actually did something like this a few summers ago at camp. I used a program called Orbiter.
Uh-huh. Ooh, I need to buy this program.
Yes, you do, because it's an actual simulation. You get to see all the different stuff you like. It's like you're in a space module.
And then do you have some mode where you can see it like this?
You have some mode where you can see it like that, except you can see stars and the actual planet, and you have to do like docking.
Fine. Yeah.
So using the whole like curved gravity thing, is that why it takes a lot of energy to like get out of the
Yeah, you got to climb up out of this.
the orbit of the Earth, and then
Yeah.
you actually need less energy to enter
Right.
the orbit?
Yeah, you just basically need to get rid of energy without burning yourself up, right?
Yeah.
Okay, and then there's a couple more things in here. There's a thing called docking. Strike the any key. I think this is one where you need to do like 30 or something like that. So here I am. There's a space station. You need to get out to the space station. But if you sort of do a frontal assault on the space station, it blows you up if you're coming in too close. Okay, so you got to come in nice and slow, or they just get rid of you. Should we try it here? Here we go. Let's speed up. Okay. Coming around. I'm going to get myself blown up.